The Turkish defense industry has once again attracted global attention after showcasing a next-generation fighter jet engine, touted as one of the most ambitious pieces of technology in the country's military aviation history. In recent years, Turkey has been steadily accelerating the development of its national aerospace technology to reduce its reliance on imported engines. The emergence of this highly advanced fighter jet engine symbolizes the renaissance of the Turkish aviation industry. Local engineers are working day and night to create high-performance engines capable of powering next-generation fighter aircraft, high-speed combat drones, and future stealth aerial platforms. Inside the world's most advanced fighter jet engine assembly line, thousands of engineers and technicians work with incredible precision. Each component is designed using state-of-the-art technology based on artificial intelligence, automated robots, and the latest generation of materials capable of withstanding extreme temperatures. The manufacturing process is one of the most complex technological achievements in the modern aerospace industry. Everything begins in the Design and Research Center. Aeronautical scientists first create digital simulations using advanced supercomputers to calculate airflow efficiency, turbine pressure, fuel consumption, and engine combustion chamber temperatures. The latest generation of fighter jet engines is designed to have a very high thrust ratio while remaining fuel efficient. The production line uses special superalloy materials based on titanium, nickel, and carbon fiber. These materials have the extraordinary ability to withstand extreme heat and high pressure without deforming. Turbine blades are among the most complex components to manufacture. Once the components are manufactured, they are sent to the main assembly line. This is where modern automation technology plays a major role. Dozens of industrial robots move in synchronization, installing machine components with a level of accuracy nearly impossible for humans. These robots are capable of installing microbolts, aligning turbine shafts, and even measuring component balance using high-precision laser sensors. Behind the grandeur of a modern fighter jet lies extraordinary technology hidden within its heart, the fighter jet engine. This engine determines the speed, agility, thrust, and extreme maneuverability of the latest generation of fighter aircraft. Currently, various developed countries are competing to create the most advanced fighter jet engines with cutting-edge technology capable of propelling aircraft to supersonic and even hypersonic speeds. In a modern production space, the atmosphere is very futuristic. The blue light from laser scanners fills the work area, while giant digital screens display real-time engine performance data. A fighter jet engine consists of several key components that must be assembled perfectly. The first stage begins with the installation of a multi-stage air compressor, which increases the air pressure before it enters the combustion chamber. Next, technicians install the main combustion chamber, which serves as the center of the engine's explosive energy. This is where the fuel and air mixture is ignited to produce enormous thrust. The next stage is the installation of the high-speed turbine. This turbine converts heat energy into rotational power, which then drives the entire engine system. The final component is the nozzle, which features thrust vectoring technology. This technology allows the engine's thrust direction to be flexibly changed, enabling the fighter jet to perform extreme maneuvers in the air. Each assembly stage requires meticulously detailed measurements. The tolerance for error in assembly is even microns. One of the most advanced features of modern fighter jet engines is thrust vectoring. This technology allows the engine nozzle to move in multiple directions. To enhance the aircraft's maneuverability, thrust vectoring allows fighter jets to perform extreme maneuvers such as the Cobra maneuver, the culbut, and even incredible high-angle maneuvers. This technology gives the aircraft a significant advantage in close-quarters air combat. On the production line, installing the thrust vectoring system is one of the most complex processes. High-precision hydraulic actuators are paired with digital sensors capable of responding to changes in pilot movement within milliseconds. After the entire assembly process is complete, the fighter jet engine is not immediately installed on the aircraft. The engine first undergoes a series of extreme tests in a specialized facility. The engine is housed in a giant test chamber designed to withstand large explosions and high temperatures. In these tests, the engine is run at various power levels to measure performance, stability, and fuel efficiency. The resulting sound is so loud that it can cause significant vibrations throughout the facility. Therefore, the test chamber is equipped with thick concrete walls and a special sound dampening system. Technicians monitor thousands of digital data points in real time from turbine temperature and air pressure to engine vibration and fuel consumption. If even a minor disturbance is detected, the engine is dismantled for further analysis. The global aerospace industry is now developing a more revolutionary next-generation engine. Future engines are designed to have higher fuel efficiency, lower heat emissions, and significantly greater thrust. Some new technologies even allow engines to operate in adaptive mode, automatically adjusting performance to combat conditions. Artificial intelligence technology is also beginning to be applied to enable engines to self-diagnose damage. Furthermore, scientists are developing ultralight-weight materials based on nanocomposites to significantly reduce engine weight. With lighter weight, aircraft will have greater speed and combat range. Major powers are now racing to develop engines for sixth-generation fighter jets, which are predicted to possess extraordinary capabilities, including the integration of combat drones, advanced stealth systems, and speeds far surpassing those of current fighter jets. The world's most advanced fighter jet engine assembly lines are more than just ordinary production facilities. These facilities symbolize a nation's technological prowess, industrial capability, and modern engineering advancement. Every bolt, turbine, and electronic system is designed with the utmost precision to produce the world's most powerful fighter engine. Behind the roar of jet engines that shake the skies lies the hard work of thousands of engineers, technicians, and scientists who dedicate their lives to creating the best aviation technology. The advancement of fighter jet engine technology also demonstrates how humanity continues to push the boundaries of modern engineering capabilities. From digital design rooms to high-tech automated assembly lines, the entire process demonstrates a seamless blend of science, artificial intelligence, and precision engineering. In the future, fighter jet engines are expected to become increasingly sophisticated, with capabilities that may be unimaginable today. However, one thing is certain: the fighter jet engine assembly line will remain the center of the most impressive technological innovation in the modern aerospace industry.